So, before we really get into this problem, it's probably not a bad idea to recap or summarize what are the steps when you're solving a kinematics problem, one-dimensional kinematics problem. You've got first, list your variables. That's literally writing down x0, v0, acceleration, and then x final, v final, and t. Writing down those 6 items. Then, fill in what you know. Now remember, what you know may not be just explicitly given in the problem. It may be something that you have to kind of interpret correctly. So for example, an object that starts from rest, well, its initial velocity is 0 then. So that sort of thing. You have to keep an eye out for situations and certain things that tell you information. For example, if you're doing a problem that involves free fall, then your acceleration is g, 9.8. Negative 9.8 is probably the best thing to do, make it directed downward. So next thing, identify the variable that you don't care about. And use that to pick the correct equation. Step 4, pick the correct equation, the best equation for this, out of the kinematics, best equation for the situation. 5, solve that equation for the missing variable, the one you want. And then 6, plug in and find your answer. Maybe 7 will make sure your units are correct on your answer. So, there we go. So for this one, we're going to start off. We're going to go, let's see, x sub 0, v sub 0, acceleration, final position, final velocity, and the time in between. So plane is traveling northward. A good picture doesn't hurt either. So your plane traveling northward when it lands. So here's our plane. Looks just like one of my cars. There you go. And we know it's got a certain velocity and it's going to stop in a certain distance by the end of the runway, hopefully. Not actually stop, I take it back. Going to go to some lower speed. We read it carefully. So it has a larger speed at the beginning and a slower speed at the end. But unlike the previous problems where they gave us time, now they're giving us distance. Okay, so I'm going to assume that we start at 0 meters again and that this 833 is where I'm going to end up. My original velocity, I'm going to go with the 69.4 meters per second. And the final velocity is 14.5 meters per second. And then we have 2 things that we don't know, acceleration and time. And they ask me for the acceleration. So time is the thing I don't care about. So if I look at these 3 equations, I need one that doesn't involve time. Well, there's time, so I can't use that one. No, not that equation. There's time, so can't use that equation. So we're down to the 3rd equation. So I write that down. Important that you write that down. Don't start plugging in right away. Okay. So we'll solve it for the variable that we need. So we want to know the acceleration. So let's see, the first thing we're going to do is subtract VO squared from both sides. That's going to leave me with V squared minus original velocity squared equals 2 times A times x minus x sub 0. Now I'm after A, so I'm going to divide both sides by 2 times x minus x sub 0. because they're both being multiplied times a, so I'm going to do the opposite. So 2x minus x sub 0 on both sides. So I've got a equals v squared minus vo squared over 2 times x minus x sub 0. Now I'm going to plug in. So I got acceleration is equal to, now final velocity is 14.5 squared, meters per second squared, minus the original velocity of 69.4. Now notice, I made the assumption that our velocity, and not a bad assumption because I think northward is a way they were going to call positive, that both of our velocities, since they're both northward, are going to be positive. So that's going to lead me over here to a negative acceleration, I believe. So 2 times my final x, which was 833, minus my original, which was 0. So if I push the buttons on that, I got negative 4,606.11 over positive 1666. So this would be in the units of meters squared, seconds squared. This would be in the units of meters, which makes sense if the units, when this meter here will cancel out one of them here. So we'll get meters per second squared. So I got 4606.11 divided by 1,666. And I get an acceleration of negative 2.76 meters per second squared. There we go. The negative indicates that the acceleration would be southward, the opposite of the plane's velocity. Hence, the plane is slowing down. All right, we're going to actually look at a problem now. It involves free fall, and we're actually going to change these equations a little bit. I'm going to rewrite them, and by that I mean the following. We're not dealing with a horizontal problem, so I'm going to get rid of the x's. I'm going to replace x's. So for a vertical problem, I'm going to replace the x's with the y's. It'll help us later on. So we're going to have that, and that doesn't change. Then we're going to have y equals 1/2. Now, what is the acceleration in a free fall situation? It is g. 1/2 g t squared plus VOT plus y sub 0. A little bit sketchy over here, sorry. Plus y, I'm not fitting it in. All right, hold on. V equals AT plus VO, and then I got y equals 1/2 GT squared plus VOT plus y sub 0. And then I have v squared equals the original velocity squared plus 2 times g times y minus y sub 0. So I'm going to replace the kinematics I have. They're the same equations. I'm just changing the changing the x's to y's basically, and all the accelerations to g. So start off the same way. My original position, my original velocity, my acceleration, which I know is g, which is negative 9.8 meters per second squared. Since we are going to assume that upward is positive then since the acceleration due to gravity is directed downward, I've got to call it negative. And then I have final position, final velocity, and time. Okay, so let's fill in what we know. A ball is thrown vertically upward, which is the positive direction. A little later, it returns to a point of release. The ball is in the air for a total time of 8.15 seconds. Very interesting. So this one, a picture is going to be very important, I think. So if we start here and we throw it upward, vertically up, straight upward, I'm going to have to move it over a little bit so it's visible, but it comes back down. There's a few ways to look at this. The total time in the air is from here up till it stops and then back down again. That's the total time that they're talking about. So I can think of two ways to handle this. I think maybe the simpler of the two ways is to consider just half of the trip from here to the top. How long would that take? So the time it takes to get to the top. Well, if it takes 8.15 seconds to go the whole thing, it's going to be 4.075. Take half of that, right? 8.15 divided by 2, 4.075. So the time to the top is 4.075 seconds. So that's one way to handle it. And we'll do that first, and then we're going to look at a second way to handle this problem. So I'm going to go, the time to the top is now 4.075 seconds, half of this total time in the air. I'm going to assume I start at a height of 0. Now, think about it now. You're looking at it, you're going, oh, but I got 3 things that I don't know, Wellborn. Wait a second. What do you know about an object at its highest point? At its highest point, what does it do momentarily? Correct, it stops. So which one is that? Is it V or VO that we're talking about? Well, that's going to be V, because VO would be whatever I threw it with. In fact, that's what I'm looking for. I'm looking for VO. So its final velocity is 0 meters per second. This is a very important point to keep in mind. Is that at a highest point, in the y dimension, the velocity will go to 0. So I have this missing, which is what I want. I don't care about y. So which one of these doesn't involve y? Well, this one right here. So I can put in that the final velocity is equal to sorry, this should be a g, right? We'll go g. gt plus VO. I'm going to solve that for VO. So VO is going to equal final velocity minus gt. All right, so I got original velocity is equal to the final velocity, which is 0 meters per second, minus a negative 9.8 meters per second squared times 4.075 seconds. Notice 2 negatives here. One that came with the formula and the one that comes with the 9.8 because it's directed downward. So that's going to make an initial velocity of a positive number, whatever 9.8 times 4.05 is. So it's going to be a positive 39.9 meters per second. That's one way to handle it. Let's look at another way, shall we? So one of the things I know in this situation is that when I throw the object upward or launch it upward, and when it comes back down, if we ignore air resistance, whatever VO was in the beginning, it's going to be the opposite sign, but the same magnitude on the way down. So in other words, the V final, when it gets to this point, I'm not worried about the top point. I'm not worried about that. Coming down, back down to here. When it launches, its VO is whatever. When it gets back to that height, when it's at that final velocity, it's really, since it's right back at the same height and it lost all of its speed and then gained it all on the way back down, it's going to have the same speed except different direction, going downward. So I can write y0 v0. Acceleration is g, which is negative 9.8 meters per second squared. Final position, final velocity, and t. And what I know here is now we're going from this location to the end right here, so the time is the 8.15 seconds. And the interesting thing is, I'll start at that height, I return to that same height, and on top of that, my velocity, my final velocity is equal to negative whatever my original is. So even if I don't know the number, I do know they're equal to the original. So there's all kinds of ways I can get this. We could even use that first equation again. We could go final velocity is equal to gt plus your original velocity. But my final velocity is the opposite of my original, gt plus VO. And I'm solving for VO, so I'm going to, let's see, I'm going to subtract VO from both sides. That's going to give me negative 2 VO equals GT. So I'm going to divide both sides by negative 2. So VO is going to be GT divided by negative 2. So my initial velocity is going to be g times t divided by a negative 2. And you're like, oh, but a negative, it's going to make the answer come out negative. No, it's not, because your g is negative, right? So the initial velocity is going to be negative 9.8 times 8.15 divided by negative 2. Negative 9.8 times 8.15, boom, divided by negative 2. Hey, what do you know? The initial velocity is 39.9 meters per second. I would also point out that you could have also used, let's see, you could have used any of the equations, I believe, because, for example, the y and the y sub 0, well, now you couldn't have used any of the equation, because this would just come out to, since you start at 0 and you end at 0, this whole thing is 0, and you would just end up with v squared equals VO squared, which we know, right? We know they have the same speed. If you square them, their signs would go, the negatives would go away. That's just a statement of the obvious. But you could have used this. I'm thinking, who wants to use that? Because you got squared and you got to solve for that. So this does seem like the better choice. So there's an example of a fairly interesting problem where what you're filling in one case isn't even a number. That's the physics of it. That's understanding that when an object, for example, comes back to the same height that it was launched from, if you ignore air resistance, if you can ignore air resistance, then it's going to have the same speed, just opposite direction.